Hi students, so now we will be solving this particular problem of integration. So the problem says that integration of sine to the power 5x dx. Alright. So whenever these kinds of problems will be given to you, then just putting the concept of direct proper substitution won't help much. So in this case, we have to first break the problem, okay, in a way that when we take the derivative, then half of the problem gets solved. How? Let me show you. So we can actually say first, what to say, okay, first let's do the derivative. All right. Okay, no, first let me break the problem. So this is our problem here, right? So I can write this entire thing as sine of, okay, square x whole square into sine x dx. I hope this point is clear to you. I have done nothing, just broken this power into three parts. First, I have taken sine square x, then a whole square of that, and then I have separately taken another sine x. So in essence, what happens here is that if you sum all of these up, then what do you get in return? Nothing but sine to the power 5x only. How? Because here it is sine square x whole square, which means the power gets multiplied. So we have sine to the power 4x here multiplied by sine of 1x, right? There is the power 1 here. So when there is a multiplication sign in between, we know that the power gets added up. So we have a 4 here and we have a 1 here. So ultimately what we get is nothing but a 5, right? So now you might ask me that what was the requirement to break this particular problem into these two different parts. You will understand it soon. Now I can write this sine square x as nothing but 1 minus cos square x, right? Other things will remain constant as it is. All right. Just in place of sine square x, I have replaced that by a 1 minus cos square x. All right. The whole square will be there as usual, and which will be multiplied by a sine x. So ultimately we will be having this particular expression. Now I think you can get a rough idea of what we will be doing next. What we will be doing next is we will be considering cos x as t, and then we will take the derivative of it, and then finally we will see that this cos x will get replaced by a t and this sin x dx will get replaced by a minus dt. How? Let's see. So first what we will be doing is we will take up cos x, let cos x is equal to t. So once we do that and then we take up the derivative, we get minus sin x dx equal to dt, right or not? So what will be our ultimate job? To replace sin x dx, right? So this minus sign will be shifting here. All right. Now let's do the substitution part. So we will get we have taken cos of x as t here, so we will get a t here. There is a power 2 here, so there will be a power 2 here. Again there is a whole to the power 2, so we will get a whole to the power 2. And in place of sin x dx, we will replace it straight by a minus dt. So minus comes out of the integration sign and we get a minus dt. Okay. So now what we will be doing next is just simple solve, right? How? This is in the format of a minus b whole square. Now don't directly try to integrate it, okay? You can do it, but I think it will be a bit messy because, you know, this might create a lot of confusion. Direct integration of this is not something that I would recommend, all right? So first, just let's break the entire thing. How? we have this entire format as a minus b whole square. Okay, so what we will get, a minus first let's do a minus b whole square, right? So what we will have here, a square plus b square minus of 2ab. So our a is 1 here and b is a t square here, right? So it will become t to the power 4 minus of 2ab. 2 is as it is, 1 is 1 and b is t square. All right, so this is the ultimate thing that we will be getting here. Okay, and next you know how to solve these kinds of integration. Integration of 1 dt is nothing but t. See, the minus sign will remain outside as it is, so we will be having a t. Next, t to the power 4 can be written as t to the power 5 by 5 after integration. Clear? Next, there will be a minus and 2 will come outside of integration. 1 is of no use. We have a t square, so we can write it as t cube by 3 divided by 3 plus c. Now the ultimate task, as we know, is to replace these t's by a cos x, which you can easily do it, and I think you don't need any help for that. Okay, so we will now move into the next problem. Please do substitute these t's by cos x, all right, and your ultimate answer will actually be minus of cos x plus cos to the power 5x by 5 minus 2 cos to the power 3x divided by 3 plus c. That will be your final answer. Okay, I'm not writing it because we have done it a lot, many times. Okay, so I hope you got a clarity of how to solve these kinds of problems. I'll give you a few more. All right, next let's say I have, say, integration of sine 4x cos 3x dx. What about it? Now that we have both sine and cos in our integration problem, how do we approach? See, here we know that we have to take up a variable. We have to consider something as a variable here and then proceed. Okay, so in this problem, let's consider that sine x is a t. So in that case, we will get cos x dx as dt, right? Pretty straightforward. Now, what we will be doing is, we will be doing a bit of manipulation, okay? Because directly using this formula, directly approaching the problem isn't very wise, all right? So how will we break this? Now, you can write this as sine 4x, right? And you can write this as cos square x into cos x dx, right? There is a 1 here, so 2 plus 1, 3 cos cube x. That is exactly what is given in the question. I'll further break it, okay? And what I'll be doing here is, in place of cos square x, I'll try to replace it by 1 minus sine square x. And cos x dx will remain as it is. So now you can understand this is nothing but a very pure form of substitution, because you can simply write this sine to the power 4x as t to the power 4, right? 1 minus sine to the power 2x, you can write it as t square, right? And cos x dx, you can write it as dt, as we have done here, right? Now, what next? Just multiply. So you will be getting a t to the power 4 minus t to the power tell me, t to the power 4, and here what we will be getting is nothing but t to the power 6 into dt. Few minutes ago only I said that the powers, when they have a multiplication sign in between, they get added up, right? So if there is a, say, t to the power 4 dot t to the power 2, then these two powers will essentially get added up when there is a multiplication sign in between them, okay? Now that you have reached this particular point, I hope integration doesn't stand as a huge issue, because you know that the integration of t to the power 4 is nothing but t to the power 5 by 5, and the integration of t to the power 6 is nothing but t to the power 7 by 7 plus c. So this is the entire problem, but you have one important work, that is to substitute these t's at the end. I have done it a lot many times, so I don't want to waste any time doing these substitutions, okay? I showed you up to here, but your task would be to actually in the next step replace this t by the sine x, as we have considered t to be sine x. So our original solution will be having the original value that was given in the question. I hope this problem is clear to you, and I hope there shouldn't be any confusion. We will solve quite many problems based on these powers, because chances are that you might get confused, okay? Initially these problems might look a bit cumbersome and difficult and many other words I can use, but trust me, these are the easiest problems, okay? They help you score really well. So if you really like my video, please don't forget to like, share, subscribe, and don't forget to hit the notification bell icon for more of such exciting content. I hope you enjoyed the video. So now let's move on to the next problem.